Hello everybody! Today I'll be doing a problem out of our textbook from Chapter 4 for our communication assignment. Problem 4.12 states that a gusset plate is subjected to the forces shown in figure P4.12. Find the magnitude and direction theta of the force in member B so that the plate is in equilibrium. So, what we need to remember is that equilibrium means that the sum of the forces in the x direction and the y direction are both equal to 0. So what you first want to do is you want to draw your free body diagram. And now I'm going to draw mine a little bit differently than the book has it to make it easier to separate our forces into their components. So force B is at an angle theta, so we're going to keep that the same. Now force C is pointing to the negative x direction at 640 newtons. So instead of drawing it there, we'll just draw it over here. Force C. And then we have force A pointing in the negative y direction. So we'll do the same thing as force C and just draw it down here. So now what we want to do is we want to separate each of our forces into their components. So force A will equal, now it's only in the negative y direction, so we'll only have negative 310 newtons J. And now force C is only in the negative x direction, so we'll only have negative 640 newtons I. And now for force B, because of this angle theta, we'll have forces in both the x and the y direction. So to keep it simple, we can just do BI plus BJ because of the fact that it's in the first quadrant, x and y are both positive. So we want to do the sum of the forces in the x equals to 0 and the sum of the forces in the y equals 0. So the sum of the forces in the x equals negative 640 newtons I from force C plus BI equals 0. And the sum of the forces in the y equals negative 310 newtons J plus BJ equals 0. So we have BI equals 640 newtons, and Bj equals 310 newtons. Now to remember, to find the resultant of these components, you have to take the square root of the squares. So force B equals the square root of 640 newtons squared plus 310 newtons squared. And that comes out to be 711.13 newtons. And now we need to figure out this angle theta. So remember that theta equals the inverse tangent of the y component divided by the x component, always in that order. And that comes out to be 25.84 degrees. So what you want to remember is that this problem's in equilibrium, so that the sum of the forces in the x equals 0 and the sum of the forces in the y equals 0. And you can always change the free body diagram based on the diagram in the picture to make it easier to separate your forces into components. And then to find the resultant, make sure you make the square root of the squares of the forces, and then you find the angle through the inverse tangent. I hope this helped.